Okay, next in line is one sample chi-square. But review muna natin ang binomial test. Last time we discussed coral colony species richness. And in this dataset, we have a dichotomous nominal variable. So high and low species richness lang. We also set a reference point that if at least 50% ng samples natin have high species richness, then there's nothing to worry about climate change at the moment. Of course, in that particular area. Again, at least 50% ng ating samples ay dapat mataas pa rin ang species richness. So, our null hypothesis should be the percentage of coral colonies with high species richness is equal to or greater than 50%. And our alternative hypothesis, the percentage of coral colonies with high species richness is less than 50%. And we have 100 observations here. Masisipag siguro mga researchers neto. Because again, 100 observations can cover a large reef area. Let's now perform the analysis. Okay, analyze non-parametric test, legacy dialogues, binomial test. And you need to transfer coral colony data to our test variable list. Now, our test proportion should be 50% or 0.5. Again, as I've said, yan yung ginawa nating reference point. Now, why choose that value? Bahala na yung mga environmental scientists dyan kung ano yung tamang value. But for the sake of teaching you this tool, okay, we set that value. Click OK. So, our p-value here is 0.089, which is, of course, higher than 0.05. So, we don't have a better choice but to accept HO that at least 50% na ating mga coral colonies ay may mataas pang species richness. Now, kahit pa sabihin natin that in our table here, 59 yung may low species richness. Okay, and 41 lang ang may high. I don't know how that works, but I think that's still within the boundaries of probability. Okay, diba? For example, for the chances na, for example, magkaanakan ng lalaki or babae ay 50-50. But there are still plenty of instances na yung isang individual, puro babae lang or puro lalaki lang yung kanyang mga anak or hindi nagpa-follow ng 50-50 na proportion. So, we're done with the assignment. I hope that you're now ready to look at one sample chi-square. For this test, our variable must be nominal and we have 3 or more groups. Sa binomial test, dalawang groups or proportion lang ng dalawang groups. But again, pag more than 2 groups na, okay, you can now use one sample chi-square. Here, we have feeding preferences of tiger sharks. Okay, baka sabihin nyo, sir, posible naman po sigurong mag-collect ng data from tiger sharks unless bantayan mo, sir. Tiger shark po yan. Tama, may punto naman. Okay, but still, direct observation is possible. You can dive, okay? Pwede ka rin gumamit ng mga underwater cameras. Yung sa National Geo, naglalagay pa nga sila ng mga baits malapit sa camera. Of course, syempre, may mga challenges sa research. You need to weigh the risks and the benefits that you can get from doing your research. There are also indirect ways to observe. Diba? Pwede mo namang huliin mo yung shark and tingnan mo yung tiyan niya. Yeah, of course, in that case, you need to sacrifice the animal to do that. Pwede ka rin mag-collect ng mga waste materials nila and perform some sort of DNA analysis or barcoding. Okay, PCR mo and compare mo sa existing databases yung mga nakain nila for identification. But again, disclaimer lang guys made up data ko lang to for educational purposes only. So we have 4 diets here. Ano ba yung magiging null hypothesis natin? Because I think walang preference yung shark. Okay, so I expect na masiba yung tiger shark. So kainin niya to lahat. So I think equal lang silang 4 in terms of preference ng shark. But of course, we will test that. Let's now start performing hypothesis testing. So our HO, so the feeding preference of tiger sharks is equal across all 4 groups. Meaning each can be assigned, let's say, 25% probability na makain siya. Given the 4 options, again, equal lang na yung probability na kainin sila. So each have a 25% chance of being eaten. Our HA is of course the exact opposite of that. The feeding preference of tiger sharks is not equal across all 4 groups. So our alternative hypothesis informs us na talagang may preference ang tiger shark. Okay, next, as usual, choose the level of significance and sample size. Alpha is equal to 0.05 and we have 80 observations here. Then we determine the test statistic. 1 sample chi-square. And of course, our critical values. If P is greater than 0.05, accept HO. Pag less than, reject HO. Now, let's do the computation. At this point, let's have a clear picture of the observations that we want to test. So, turuan ko muna kayo mag-generate ng frequency table and graph. Now, click Analyze, Descriptive Statistics, Frequencies, transfer the variable of interest you want to test here. Take note, since nominal data lang to, all we can do is count the number per diet. Display frequency tables. Click on charts, then choose bar charts. Actually, pwede din pie. So it's all proportions lang naman yung ilalabas. So it's your choice. Pwede din frequencies or percentages. Click continue. Okay. Here's your frequency table and your bar chart. 15 small fish, 14 crustaceans, 21 squid, 30 large fish. Okay, lagyan muna natin ng label tong graph. Actually, pwede mong i-edit yung graph, especially ang formatting. Of course, parang may ilagay kang magandang figure sa paper mo. You can actually increase font sizes or change colors. It's all here sa properties. Okay, saglit lang. Just observe. Mag-edit muna tayo. What can you notice? Mas marami yatang large fish ang kinain ni tiger shark dito. So take note na hindi pa tayo nakapag-perform ng analysis. So raw data pa lang yan. Now, na medyo may idea na tayo sa data natin, okay, perform na natin yung analysis. Okay, click Analyze, Non-Parametric Test, Legacy Dialogues, chi-square. Transfer our variable to test variable list. Dito sa expected values, dito tayo mag-set ng proportions. Okay, take note na yung null hypothesis natin ay equal ang preference. So, we select all categories equal. Okay, we have another option here. But don't worry, yung next assignment nyo is ito yung i-choose natin sa assignment. So, for now, assuming equal lang. Okay, click OK. In this table, we have observed and expected values. 15 small fish, expected is 20. Crustaceans, 14. Squid, 21. Yung mataas talaga is the large fish. So let's look at a SIMP-SIG or our p-value to confirm na hindi equal ang preference on these 4 diets. And it's 0.04, which is lower than our 0.05. We therefore reject HO and claim that the feeding preference of tiger sharks is not equal across all 4 groups. So I think there's more preference for large fish. If you want, guys, you can run it again and then maybe you can change the proportions in your null hypothesis. So try natin yung maybe 0.2, 0.2, 0.25, and 0.35. See, our asympsig is 0.98, meaning ito yung mas probable na preference. Meaning mas type ng tiger shark ang malalaking isda and we have 35% chance na ito yung kakainin niya. Of course, next yung squid, 25% chance, and 20% chance yung crustaceans and small fish. I hope this was helpful. So as usual, okay, check the data set next to this. Assignment na naman yan. And I hope you're doing it on your own bago i-check ang next tutorial. Now, what do we have here? So this is dissolved oxygen levels in Iloilo River. So we have 100 samples. And ano yung gagamitin nating proportion dito? Now, in a river, since pwede din natin itong i-divide into distinct regions or areas, of course, nag-fluctuate din ang DO in the entire area of the river. I asked AI kung ano yung usual na proportion in a river. Okay? And the answer is 20% daw yung chance na low DO. Yung common or average DO is yung nasa 4 to 8 milligrams per liter, and you have 60% chance of encountering that in a river. And yung high DO samples is also scarce, nasa 20% chance lang din in a healthy river. So we have 20, 60, 20. So please use these proportions para consistent tayo. So 20% low, 60% moderate, and 20% high. I don't know yet kung consistent din yung Iloilo River dito. So again, disclaimer, made up data lang to. Okay, see you in the next tutorial. Bye for now.